When you add more than one target to a folder in a DFS namespace, the namespace server sends referral containing all of the targets to the clients attempting to access that folder. The client tries to connect to the first target in any referral it receives, and if the first target is unavailable, try to access the second and then the third, and so forth. As a result, the order of the targets in the referral is critical. If the DFS implementation is to successfully provide users with local files access and control web traffic levels, you want to configure the DFS referral order. By default, when a DFS client attempts to access a folder with targets, the namespace server notes the sites where the client is located and its referrals. Lists the targets at the same site first in random order, followed by the targets at other sites in order from the lowest to the highest cost. You can modify this default behavior in many ways. By manipulating the referral controls from the properties sheet from every namespace, target folders, and target. In a namespace property sheet, on the referral tab, you can change the ordering method value, which alters the way in which the server specifies the targets at different sites from the client. It usually uses the following values: the lowest cost, random order, and the exclude targets outside of the client's site. The fact that the targets in the same site as the client are supplied in random order by default, it usually gives you a balance the client's load among the server at the site. Selecting the random order option for ordering method value does the same load balancing for the targets at other sites. Selecting the exclude targets outside of the client site options prevents the client from accessing targets at other sites. In this way, you can conserve one bandwidth. However, that the ordering method value does not affect the order of the targets at the same site as the client, which always appear first in the reference and in random order. In a target folder property sheet on the referral tab, you can configure the name server to restrict its referral for that folder only to the server at the same site as the client. In the target property sheet on the Advanced tab, you can override the referral ordering values for the namespace and the folder containing the target by selecting one of the following options: first among all of targets, last among all targets, first among targets of equal cost, and last among targets of equal cost. These individual target settings are most useful when you have copies of a target folder that you only want clients to access as a last resort. For example, you might have a host standby file server on the network in case another file server fails. To streamline the failover process, you can add the shares on the standby server as targets to the appropriate DFS namespace folder, so that you don't have to take the time to do this if a server failure should occur. You don't want users to access the standby server unless there is a failure. So you can configure all of the targets with the last among all target options, so that no matter what site clients are in, they will never access the standby shares unless all of the other copies of the shares are offline. Also, we have the client fallback, which is the ability of the DFS clients to revert to targets that were previously unavailable when they become available again and are of lower cost than the target the client is using at the same moment. For example, if a client cannot access the target at the same site because the server is offline for any reason, it will access the lowest cost target at another site. When client fallback is enabled, the client will revert to the target at its same site when it becomes available. You can enable this cool feature, in my opinion, the client fallback, for an entire namespace by selecting Clients Fallback to Preferred Targets checkbox on the referral page of the namespace property sheet. You can also enable the client fallback for individual folder by selecting the checkbox on the same name of the referral tab of its property sheet. And finally, but not less important, we can configure the DFS replication or a replication group. When a folder in a DFS namespace has multiple targets, the intention is for the taggers to be identical, so that the users can access the file from any one of the targets invisibly. However, in most cases, users modify the file in a folder as they work with them, which causes the targets not to be longer identical. To resynchronize the target folders, DFS includes the replication engine that automatically propagates changes from one target to all of the other ones. To enable the replication for a DFS folder with multiple targets, you must create a replication group, which is a collection of servers known as members, each of which contains a target for a particular DFS folder. In simple form, a folder with two targets requires a replication group with two members, the server hosting the targets. At regular intervals, the DFS replication engine on the namespace servers triggers the replication events between the two members using the RDC protocol so that their targets folder remains synchronized. The DFS replication need not to be simple. However, it is also highly scalable and pretty easy to configure, to be honest. A replication group can have up to 256 members with 256 replicate folders, and each server can be a member of up to 256 replication group with as many as 256 connections. A member server can support up to 1/3 of replicated files with up to 8 million replicated files per volume. In addition to scaling the replication process, you can also configure it to occur at specific times and limit the amount of bandwidth that it can utilize. This enables you to exercise complete control over the WAN bandwidth and utilized by the replication process. The larger the DFS deployment, the more complicated the replication process becomes. By default, replication groups use a full mesh topology, which means that every member in a group replicates with every other member. But for those small DFS deployments, this is a satisfactory solution, but on larger installation, the full mesh topology can generate a huge amount of network traffic. In cases like this, you might want to opt for the hub topology. Some people call it a spoke or pod topology. I don't know why, I don't like it. Which enables you to limit the replication traffic to a specific pairs of members. So not all of the members are communicating with others, just specific members are communicating with some specific other members. No matter which topology you use, the DFS replication between two members is always bidirectional by default. This means that the replicator folder wizard always establishes two connections, one on each direction, between every pair of computers involved in a replication relationship. This is true in the hub as well in the full mesh topology. To create unidirectional replication relationship, you can either disable the selected connections between the members of a replication group in the DFS management console, or use the share permissions to prevent the replication process from updating files on certain members. When you initially configure a DFS replication group, you will designate one server as the primary member of the replication group. During the replication process, the files from the server that you designate as the primary member will be copied to the other targets in the replication group. If any of the files in one target folder are different from their counterparts in the others, the DFS replication will use the primary member version to override all of the other versions. Once you have created the replication group, it appears under the replication node in the scope pane of the DFS management console. And to finish our lesson, we're going to talk about managing Windows Server 2008 with this File Server Resource Manager. The FSRM allows administrators to perform various tasks in managing file and disk volumes through the FSRM console. These tasks can include the managing file and disk quotas, the screening files using built-in and custom templates, and the creating reports on storage resources. In previous versions and current version of Windows Server, the NTFS formatted drive offered these quotas based on user usage per volume. With the File Server Resource Manager, you can now work with quotas at the file level as well. Use quotas for both monitoring space usage and enforcing a space use limit. The FSRM quotas uses actual file size instead of the logical file size. The quotas are divided in two types, hard and soft. Hard quotas do not allow users to exceed the set limit. This type is used to enforce a storage limit. The soft quotas allow users to exceed the set limit and should be used only for monitoring purposes. Then we have the screening files using the built-in and custom templates, which is another feature of the File Services Resource Manager. The filter screening allows administrators to block specific types of files from being stored in Windows Server 2008 file directories. Filters can be defined by using built-in templates or custom create templates or by a specific file type. Filter screening is also available through the File Services Resource Manager console. And finally, but not less important, we have the creating reports on the storage resources. One of the responsibilities of managing a Windows network is forecasting drive space usage. Without data to support how much space users and applications use, it is very difficult to determine when you might run out of storage. Using the reporting feature in the File Services Resource Management, it can help you to forecast space needs and plan for deploying additional storage. The FSRM reporting can also identify the types of data being stored by the users. Class, I hope you enjoyed this lesson as much as I did. I know that many of this stuff you are really familiar with it, but if you have any question, please feel free to post them on the discussion board or ask them during our classes on campus.